Hi there, Mr. Oregon. I am now working on section 6.4 in our geometry textbook. This is rhombuses, rectangles, and squares. And I believe I'm going to call this 6.4a because I want to go through the formulas and theorems of this section. And then there are some very interesting problems that we have done in class, but that I'd like to do on video, which involves some algebra, and I like to throw that in, as my students know, because it's a good review of the algebra you're going to need for Algebra 2 next year. So for the moment, let me just run through these various definitions and theorems. This is rhombuses, rectangles, and squares. So you'll recall we had on our family tree, we had the parallelograms. Up here we had the polygons, and then the quadrilaterals, and then the parallelograms. Now, parallelograms divided off into a rectangle and a rhombus, and then a square, which is the product of the marriage of the rhombus and the rectangle. So the squares are the babies. Now, let's see. A rectangle is a parallelogram with four right angles. So remember, parallelograms have all their various features up here, opposite sides, parallel and congruent and all that. But when you straighten it out, in a sense, tilt it up to 90 degrees, then you get a rectangle. Like this, except maybe the sides would be a little straighter, and all four angles are right angles. If you keep it tilted like this, so you don't have right angles, but you do make all four sides congruent, then you have a rhombus. So you don't have right angles, but you do have the four sides congruent. And then, of course, if you take those two and put them together, you get the square, which has both the right angles and the four sides congruent. So here, 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 and here are your right angles. These four are all congruent, and now it's a square. All right. Now, we have a few corollaries here. What the corollary is a kind of the baby of a theorem. So you have a theorem, and then there's something that follows from that theorem that doesn't quite reach the ranks of a full-blown theorem itself, so we call it a corollary. The first one is a rhombus corollary. A quadrilateral is a rhombus if and only if it has four congruent sides. Over here. The rectangle corollary, a quadrilateral is a rectangle if and only if it has four right angles. And the square corollary, a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay? Now there are a few features of rhombuses and rectangles that we have theorems for. So let's take this away and we'll take a look at those four. The first one is a theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So here is a parallelogram, and if its diagonals meet at right angles, right here, then it's a rhombus. Okay? So you don't have to know that the sides are congruent. As long as the diagonals are perpendicular, then it has to be a rhombus. Okay, a parallelogram is a rhombus if and only if, by the way, notice the if and only ifs here, they are biconditional statements, if and only if each diagonal bisects a pair of opposite angles. So let's leave these up here. If this is congruent to this, this is congruent to this. Now, we knew from a parallelogram that opposite angles are congruent. So if this angle is bisected to make these two congruent, these two would also be congruent to these two, because this one bisects this angle over here, and these two angles originally were the same. Same over here. These two angles congruent to these two angles. All right, those are the two theorems that apply to rhombuses, or rhombi, and the one that applies to a rectangle is this. Let's draw a rectangle here. and this one also has to do with its diagonals. Now, we had, again, a parallelogram was a quadrilateral in which the diagonals bisected each other. But now we have something more. A parallelogram is a rectangle if and only if its diagonals are congruent. So this diagonal is congruent to this diagonal, and if they bisect each other, then this, and this must all be congruent to each other. Okay, those three theorems are the main ones that you have to have for this chapter. Now, the way these problems are presented in the book, I don't think they are terribly difficult. I know my students always say, well, yeah, Mr. Orbit, you're a math teacher. Well, and that is true, but the ones I want to do for you in the next video are considerably more interesting. And of course, my students say interesting to me is not necessarily interesting to them, but that's hopefully changing as we move along here. This is 8x minus 13 and 7x plus 11. Okay, if this is a rectangle, which you are told it is, then this is going to be equal to this. So 8x plus minus 13 is equal to 7x plus 11. So subtract the 7x, I get x over here, equals, add the 13 and I get 24. So x equals 24. There was a problem here that was, a couple of these problems I think I should do on this video before I move on. One of them looked like this. It was a square, and the diagonals intersected like this. And if it's a square, by the way, a square is a rhombus. So the diagonals must be perpendicular. Now, you were given that this is the square root of 2 and that this is 2. And you were asked to find let's label these. G, H, J, K. G, H, J, K, and in the middle is point L. Now, you're asked to find HK. All right, that would be this. Well, if the diagonals, remember it's a square, so this is equal to this, is equal to this, is equal to this. So square root of 2, square root of 2, square root of 2. All right, so you were asked to find HK, which would be square root of 2 plus another square root of 2, which is 2 square root of 2. Then you're asked to find angle KLJ. That would be angle KLJ right here. Well, we know that this intersection is perpendicular, so that must be a right angle, so 90 degrees. You were asked to find angle HJG. That would be this angle here. This angle, remember, this is a right angle, and this diagonal bisects it, so this has to be 45 degrees. And the last one is the perimeter of triangle HJK, which is this, let me outline it in blue. It is this triangle here, and that is, okay, hopefully on the video you can see that. So we have, it's a square, so that's 2, that's 2, that's 2. So we have 2 plus 2 is 4, plus these two square root of 2. So the answer is 4 plus 2 square root of 2. Okay, there was one other one here that was worth looking at very briefly. It was this problem, and it was a rectangle, WXYZ. WXYZ. And let's see, you are told the perimeter is 24, and you are told that xy plus yz is 5x minus 1. So these two sides together are 5x minus 1. And you are also told that xz is 13 minus x. 13 minus x. And you are asked to find wy, which is this. Now remember, the diagonals are going to be the same. So we can find x, we can plug it in here and find xz, and that will tell us wy because they're going to be the same. So if the perimeter is 24, we're going to say these two together make 5x minus 1 plus this is 13 minus x, and that must equal 24. This triangle is the triangle XYZ is what we're interested in, and that's this triangle here. I should outline it, but a little better than that maybe. Outline it in blue. It's this triangle we're interested in right here. Okay, so we have the perimeter, which is this side plus this side, 5x minus 1, plus this side, 13 minus x. We add them together, and we get 5x minus x is 4x. 13 minus 1 is 12, so I subtract 12 from both sides, equals 12, so x equals 3. If x equals 3, then this side length must be 13 minus 3, or 10. And if that's 10, that's 10. So the answer to problem is wy equals 10. All right. Those are the two problems I wanted to do in this section. However, in the next video, I'm going to do some challenge problems from section 6.4 before we move on to trapezoids and kites in section 6.5.